Well, I'm here as a result of Reg Coates' prod on the internet some time ago. Thanks for that, Reg. But it was a good thing to be pushed along, and I was asked to do videos. Rather than do some wow factor video that everyone does like, and they are fun, but it's actually going down a path of demonstrating what you can get away with or what's possible. And I thought better than do that, I'll go back to basics and I'll do a series of small short videos on the nuts and bolts that make up what I regard as good, competent base knowledge, underpinning knowledge and skills. So here we go. This is the first part of natural crotch rigging. I'm doing a session inside. It's a bit cool out there for me. What we're going to do is discuss some of the basics down here, and then later on I'll do part two up the tree where we apply what we're talking about and show it actually practically working. Back in the mid-70s when I was using it and I was in the industry then, that's all we had. We didn't have any fancy equipment, and so we did perfect that and get our rotations or our cycles of doing the job down to a fine art, and the control of the limbs and sections was of a high standard. In the sort of late 90s to 2000 and plus, there was an influx of equipment and gear, and pushed by equipment suppliers, manufacturers, trainers and arborists in general, trying to be probably more technical than needed to be. They seem to avoid some of these basic things. What we've found now is a resurgence back towards the natural crotch rigging, and it appears to me that a lot of people are relearning or reinventing the wheel, and it's a shame because it is a very simple, straightforward process. It has distinct advantages and there are some disadvantages as well. I first of all would talk about the natural crotch rigging with the lowering points. There's two parts to a natural crotch rigging. There is a lowering point and a friction that's got to be added at times to take control of heavier limbs. So let's deal with the lowering point. That needs to be in a position that's good for the climber. Sometimes it's good to take the material away from the climber so that he's not having the material come down near him and the ropes aren't running past him. Second part is the friction. Friction can be added around the trunk of the tree, which is time consuming because every time you do that you've got to pick the coil up, walk around the tree, take in, lower the branch, take your coils off again around the tree, pull the rope, end of the rope back to the climber. You can take the friction at the point of cut, and that means it's very handy for the climber to be able to take over if he needs to. That removes the need for an extra person on the ground sometimes. It may be the two people that needed to turn a branch on its side with near obstacles. And the other is to use a lowering device to the tree you're on or onto another tree. So the next thing to cover on this is considering what happens, how are we taking control, and friction of course produces heat. And that heat, obviously if it's running over a limb or even around a limb where it's taking turns, that heat's going to potentially do damage to the bark and the rope obviously. So we need to do this technique essentially on trees we're removing, or where we're going to remove the section of tree that's going to be obviously affected by the heat. The heat production can be severe at times to the point that the synthetic fibre ropes will in fact melt into the bark and or wood of a tree. If the bark is torn off with the weight of the limb and rope, the fibres themselves can actually become molten, and then when the rope stops moving it solidifies into the grain of whatever's there. So when that's happening, of course, we are doing significant damage to the rope and sometimes the tree. Given that most of my work, 90–95% are removals, this is a technique that's very handy for me. Then we have to look at the philosophy of your ropes. And this is the watershed in a lot of people in the industry. If your philosophy is to have expensive ropes, then obviously you need to look after them. You'll set a block, you'll have friction devices, and you'll minimise the wear and tear on those ropes. I come from the other side of the fence where, yes, I have a lot of expensive ropes and I do look after them. Majority of my work is done on fairly cheap ropes, which I consider to be consumable. So I use a lot of polypropylene ropes. If they are degraded or I feel that they're not reliable anymore, I downgrade them or dispose of them and buy some more. The next consideration is the ultimate loading on your lowering points, and that's one of the big advantages of taking natural friction. If our rope goes over the top of a high point, it actually consumes some friction as it does that, as opposed to a block, which is a very low friction point. So we're reducing the overall loadings on the high point. If the load is, say, 1/2 tonne, it'll require another 1/2 tonne approximately to hold it in position with a block in place. If we use natural friction, by going over the high point, it'll be significant or some distance less than 1/2 tonne to hold it in position because of the friction on top. Then if we take the extra friction at the point of cut, it means when the limb has stopped moving, essentially there's only 1/2 tonne loading on our lowering point. And that can be a great advantage if you're in fragile trees or you're looking to reduce the loadings down the trunk. Next consideration for natural crotch rigging is that if you take your turns around the trunk of the tree, invariably when the branch or object gets lowered, your rope that's coming down that's got the load on it comes over the top of where your friction is. And that can jam the load up to where you need to lift it or pull it away from the rope that it's locking onto. If you're lowering fairly large, broad limbs, then as that comes down, they always tend to want to catch on the rope as it wraps around the trunk, or where the grounds people walk away from the base of the tree with their rope, because it wants to come down and catch their rope all the time. So there's big advantage in having the friction at point of cut, because once the limb is hanging in the tree, the tail of the rope can be taken out of the way from where it's being lowered. The climber can take over and save that person on the ground and make it a lot easier to get back onto the ground. How efficiently that's incorporated to return the rope to the climber and get the next limb on is up to the crew to establish good skills, communication, and get a flow of the job happening. If you were to, on some of our larger trees out here, if you were to climb, say, 150 to 200 feet to put your block up the tree, by the time even a reasonable climber has done that, someone like myself could potentially have 1/3 of the limbs off the tree already with natural crotch rigging. So I've got a giant head start on someone who wants to climb to the top of the tree each time. Either technique isn't the only answer. You've got to have a bag of tricks and drag out the technique that's best suited to the situation, your manpower resources, and the situation that you're in. So natural crotch rigging shouldn't take over everything. It should be something you pull out when required. It's important, if you've got natural crotch rigging going, you need to have a program where you look after your ropes and manage when to exit them from their service. There's no point having a ad hoc system where you turn up to work, you drag the Old Faithful out, and Old Faithful's glazed and scored and bits hanging off it, because once it glazes, you bend the rope, that because it's molten, it actually breaks that section of the exterior of the rope. And this continues on with repeated lowering, especially on pine trees, they cop it. Then of course, you've got to have a system that exits that rope from the system and has another good one ready to use. So natural crotch rigging comes at a cost, and it also costs you management.